Hi, how do we go about solving for x in this equation? I'll try a different approach to my first video. I multiplied both sides by 8 because both 4 and 8 are factors of 8. And this will clear to give us 2 here, 2 times 3, which is 6, to x minus 1. And the 8 will clear with this 8 to give us 5 into 2x minus 4. And now we can clear the brackets with the whole numbers to give us 6x minus 6 is equal to 10x minus 20. Which gives us minus 4x is equal to minus 14, which gives us that x is equal to 3.5. Or 14 divided by 4, 4 3 is 12, and 2 over 4, which gives us a half. How do we know if our solution is correct? Well, we should always check. And here is the check. We'll substitute in both the left and the right hand side. So we'll start with the left. We have 3 over 4 into, we'll use 14 over 4 as x, and that 1 we'll write as 4 over 4 to make it a lot easier to manipulate. And this will give us 3 over 4 times 10 over 4 simplified to give us 15 over 8, which we can write 8 1's 8 and 7 over 8. So that's the left hand side. If you look at the right hand side, we'll have 5 over 8, 2x, it's 2 times 14 over 4, will give us 28 over 4, and we're subtracting 4, and 4 is the same as 16 over 4, so you have a common denominator. So 16 over 4 is an equivalent fraction to 4 over 1, and this is equal to 5 over 8 times 12 over 4, which simplifies to 15 over 8, which is the same as 1 and 7/8. So our check shows that our solution, x equal to 3.5 or 14 over 4, conveniently used here, is the solution to this equation. Thanks for watching. I'm Alistair. Bye for now. Hello. How do we solve this simple equation in T? When we have fractions, our aim should be to get rid of them, turn them into whole numbers. Another way of looking at this is that we're going to cross multiply here. In this direction will give us 16, 4 times 4, and then we have brackets t minus 2. And here, 5 times 1 gives us 5 into 2t add 8. This is a lot simpler to work with than using fractions to clear the brackets. So we have 16t minus 32 is equal to 10t add 40. This will give us 6t is equal to 40 times, add to 32, which gives us 72. Gives us t is equal to 12. But how do we know if we're correct? We should always check our results. We start with we check the left hand side. We have 4 over 5 and t is 12 minus 2. That's 4 over 5 times 10, which is 8. If we do the right hand side, a quarter, it's 2 times t, which is 12, add 8. And this is equal to, this is 24, add 8 is 32, and a quarter of 32 is 8. So this check shows that our result, t equal to 12, is correct. It is a solution to this equation. Thanks for watching. I'm Alistair. Bye for now. We need to solve this equation, and the reason I've chosen this is because I have students who have problems, particularly with the right hand side here. 1 minus 4 into x minus 2. They attempt to do a subtraction first. Now, first we'll clear the brackets. I like to say that rather than say expand the brackets, because there'll be no brackets by the time we've finished here. So we clear the brackets. We have 3x, add 3, add 6 is equal to 1. Now this negative 4 is multiplied, or will be multiplied by everything in the bracket. It's not taken away from 1, it's simply added. So if we were to rewrite this, we can write it as 1 add brackets negative 4 into x minus 2. That's how it would look. So that's how we're going to approach this, which will give us 1 add, or we'll make it now minus because this is minus 4x add 8. So we have here 3x add 9 is equal to 1 minus 4x add 8. Now what we have to do now is to group like terms, rearrange and simplify. So if we add 4x to both sides, we'll get rid of 4x on this side, and it comes here, add to 3x to give us 7x. Now we have 9 here, 8 add 1 is 9, and if we add negative 9 to this side, we get rid of it from here, and it becomes negative 9 on this side, so we have 9 minus 9, which is equal to 0. So we have 7x is equal to 0, x is equal to 0. Now this might look a bit strange, but why? X is a number just like any other number, and it is a solution. Let's check and see if it is a solution. If we have x at 0, then we have 3 into 0 add 1, add 6, so this is the left hand side. This will give us 3 times 6, which is 9. So this is the left hand side of the equation. The right hand side will be 1 minus 4 into 0 minus 2. So here we get minus 4 times 0, which is 0. So we have 1 minus 0, minus 4 times negative 2, which is 8. And this also gives us 9. So we have the right hand side being equal to the left hand side, which indicates that our solution x equal to 0, though it might look a bit strange, is the solution to this equation. Thanks for watching this video. My name is Alistair Harris. Keep practicing, and I'll see you on the next video. Bye for now. Hi, how do we solve this? Well, one way of doing it is by multiplying both sides by 20. And that way we get rid of the fractions. It's a lot easier to work with whole numbers. So if we multiply the left hand side by 20, the 5 will cancel a 20 to give us a 4. So I now have 16 brackets t minus 2. And on the right hand side we'll have a factor of 5, because 20 divided by 4 is 5. Or a quarter of 20 is 5. Now we can clear the brackets. 16t minus 32 is equal to 10t add 40. We can rearrange and group like terms. So we'll have the 10t move across to this side, will become negative 10t, and added to 16t will give us 6t. Now the negative 32 on this side becomes positive 32 to give us, added to 40 to give us 72. And so t now is equal to 72 divided by 6. Our answer is 12. And so we've solved our equation by finding t, which is 12. You can verify that by substituting for t in the original equation. My name is Alistair. Thanks for watching this video. Please like. If you have any comments, they're welcome to. Please follow and subscribe for more videos like this. Thanks, and bye for now. This is an example of the remainder theorem, and we have this situation occurring when we have a polynomial and it's divided by a linear function, x minus 2. So we need to divide first x cubed by x minus 2, and we can see that if we multiply by x squared, we can certainly get at least the x cubed. If we multiply our quotient here by x minus 2, we have x cubed minus 2x squared. And just like how we did long division in primary school, remember we're adding negative 7, or we're taking away, sorry, negative 2 from negative 7, or negative 7 take away negative 2, which will give us negative 5x squared. We bring down to 6x, and we bring down the negative 2. Next, we want to get 5x squared, so if we multiply, if we have minus 5x, that will give us the minus 5x squared, which is this part, and then we'll see what remains. So we have minus 5x squared add 10x. Again, it's minus 5x squared minus 5x squared, so this cancels, and it's 6x minus 10x, which gives us minus 4x, and we bring down the negative 2. And with that, if we multiply by 4, we can at least, in fact negative 4, we can at least get the minus 4x. Minus 4x, and we have add 8, because that's minus 4 times minus 2, which is positive 8. And this cancels with this, and this is minus 2 minus 8, which is negative 10. So we basically have divided a polynomial, as in x, by a linear function. We got our quotient, which is x squared minus 5x minus 4, and we have a remainder of negative 10. So if we were to write this as a generalized form, we can write that f of x, which is our polynomial, is equivalent to x minus a. This is the linear function we're referring to. If we multiply that by the quotient, we call the quotient q of x. Q of x. Let's rewrite that. F of x is equivalent to x minus a. Q of x. So that's the divisor here, q of a, multiplied by the quotient, and we have a remainder, which is r. And if we add r, then we'll get back to the polynomial that we started with, x cubed minus 7x squared at 6x minus 2. Thanks for watching this video. My name is Alistair. Any questions or comments are welcome. Please like and also follow or subscribe for other videos like this. Thanks and bye for now. More on the remainder theorem. In the previous video, I ended up writing this f of x being equivalent to the divisor times the quotient at the remainder. In terms of the function, the polynomial being divided by the linear function, we had f of x was actually x cubed minus 7x squared at 6x minus 2. That's actually equivalent to x minus 2. Our quotient x squared minus 5x minus 4, and our remainder is 10. So this is f of x. So the divisor times the quotient add the remainder gives us our function. Now if we substitute a for x in this identity, then this becomes 0 and all of this becomes 0, and we're just left with r. So if we write that f of a is now equal to r, because we substituted in terms of x, we substituted a, which sends all of this to 0, we're just left with r. Now this result is known as the remainder theorem. So it states that when f of x is divided by x minus a is divided by x minus a, that's the linear function. In this case it was x minus 2. The remainder, the remainder is f of a. So, just to recap, I've stated algebraically what f of x is equivalent to, which is x minus a, its divisor times its quotient at the remainder. Now we've expressed that in terms of the function polynomial and the linear function that we used. Here we found f of a, that's substituting a for x, and that sends all of this to 0, and we just know that now f of a is actually r. And this is the formal statement of the remainder theorem, is when f of x is divided by x minus a, the remainder is f of a. Thanks for watching this video. My name is Alistair. Any questions, comments or requests are all welcome. Please like, and don't forget to follow or subscribe for more videos like this. Bye for now.